Parallel universes are one of the most fascinating and often misunderstood ideas connected to quantum physics. While it sounds like science fiction, there are serious scientific discussions about whether multiple universes could exist and how quantum mechanics might suggest their existence. In this video, we will explore the concept of parallel universes, what quantum physics actually says, and what remains speculative. The idea of parallel universes is often linked to the many worlds interpretation of quantum mechanics. According to this interpretation, every time a quantum event with multiple possible outcomes occurs, the universe splits into separate branches, one for each outcome. This means that every possible result of a quantum measurement actually happens, but in different, parallel worlds. For example, imagine a single qubit in a superposition of 0 and 1. When measured, it will be observed as either 0 or 1. In the many worlds view, both outcomes occur, but each in a separate branch of reality. You might experience seeing 0, while in another universe, an identical version of you sees 1. In principle, all possible outcomes are realized somewhere in the multiverse. It is important to emphasize that this is an interpretation of quantum mechanics, not a proven fact. The many worlds interpretation offers a mathematically consistent way of understanding quantum superposition and wave function collapse. But it is one of several interpretations. Other interpretations, such as Copenhagen, pilot wave theory, or objective collapse models, explain quantum phenomena without invoking multiple universes. The parallel universe idea also raises philosophical questions. If countless versions of reality exist, what does that mean for identity, choice, and probability? While fascinating to think about, these questions do not yet have scientific answers. The interpretation is primarily a tool for understanding quantum mechanics and its predictions, rather than a testable claim about reality. Some people link parallel universes to science fiction scenarios, such as time travel, alternate histories, or meeting another version of yourself. While these ideas are imaginative and fun, they go far beyond what the physics actually predicts. The many worlds interpretation does not allow communication or travel between branches. Each branch evolves independently once it splits. Quantum physics also connects to parallel universes in subtler ways. For instance, interference patterns observed in experiments, like the double-slit experiment, can be interpreted as evidence that all possible paths a particle could take are part of a larger, superposed quantum reality. In many worlds thinking, interference results from the interaction of these branches before they decohere. Decoherence is key to understanding why we do not perceive multiple universes directly. When quantum systems interact with their environment, superpositions effectively collapse into classical outcomes. The branches become independent, and the alternate outcomes are no longer accessible to our experience. This explains why our world seems single and continuous, even if multiple quantum possibilities exist in theory. It is also worth noting that parallel universes are not required to use quantum mechanics. Quantum theory works perfectly well with only one universe. The idea of multiple universes is a conceptual framework to make sense of superposition and measurement, rather than an empirical necessity. The concept of parallel universes has also inspired speculative ideas in cosmology. Some cosmologists propose that different regions of spacetime might have different physical constants or histories, creating a kind of multiverse. While these ideas are related in spirit, they are separate from the quantum mechanical many worlds interpretation. Quantum physics, therefore, offers a glimpse into a reality that is stranger than everyday experience. The possibility of parallel universes challenges our intuition about uniqueness and determinism, suggesting that what we observe is only one branch of a vast landscape of possibilities. Understanding these ideas requires care. Many popular descriptions exaggerate or misinterpret the science. The true lesson from quantum mechanics is that nature at small scales behaves in ways that defy classical expectation. And multiple, equally valid frameworks exist for understanding this behavior. In simple terms, parallel universes in quantum physics are a way to explain the weird outcomes of quantum events. They might exist, or they might not, depending on which interpretation of quantum mechanics one accepts. What is certain is that quantum theory accurately predicts experimental results, whether or not multiple worlds are real. Thinking about parallel universes also reminds us of the depth and mystery of the quantum world. It is a universe, or possibly many universes, where the rules of reality are more flexible and interconnected than we might have imagined. Ultimately, parallel universes and quantum physics sit at the intersection of science, philosophy, and imagination. They encourage us to question assumptions, explore possibilities, and appreciate that reality may be far richer than what we perceive.